अस्सलाम वालेकुम याहिया साहब, आप मुझे सुन रहे हैं?
यस सर, वालेकुम सलाम।
भाई आपकी क्लास गायब थी, आज क्यों नहीं आ रही? अभी भी देखिए, क्लास शुरू होने से 10 मिनट पहले आके लॉग इन होने चाहिए ताकि मैं उनको एडमिट कर सकूं।
यस सर जी, हम लॉग इन थे, आपने वो लिंक ही नहीं सेंड किया था, अब लिंक है।
और नहीं सब बकवास करते हो। मैंने इतवार को भेजा था लिंक, इतवार को भाई, तीनों मीटिंग का लिंक इतवार को भेजा था, आज दोबारा भेजा है मैंने। सब झूठ बोलते हो। 17 आदमियों को भेजा है, सिर्फ एक का नॉट डिलीवर्ड हुआ है, बाकी सबको डिलीवर हुआ है। आपको कैसे नहीं मिला? कहाँ देखते हो तुम लोग अपना ईमेल?
सर मोबाइल पे।
मुझे नहीं पता, मोबाइल पे भी नजर आना चाहिए। आपका जो भी ईमेल है, मैंने आपको उस ईमेल पे मेरा ग्रुप बना हुआ है, उस ग्रुप में आपको अभी तक नहीं मिला, तो ये कैसे मिल गया?
सर ये नयान आ गया।
हाँ
यस सर, मिल गया।
हाँ, ये भी बताना पड़ेगा कैसे अपना ईमेल कैसे ढूंढो। इतने मासूम लोग हो तुम लोग, इतने अनपढ़ और जाहिल लोग हो, इंजीनियर बनने जा रहे हो, तुम्हें नहीं पता ईमेल कैसे ढूंढा जाता है? तीनों ईमेल मैंने संडे को भेज दिए थे। Now without wasting time, let me start meeting. Bismillahirrahmanirrahim.
सबसे पहले
Now
तो
I've
आपको
got
बताना
only eight participants, and they will be continuing coming, and this is also not good. So they should join before 10 minutes before the time starts. Time starts on Tuesday, on Wednesday and Thursday. It starts 12:25. My time is 12:25 for 2 days. On Wednesday and Thursday. And my time is 11:15 on Tuesday. So remember this.
Yes, sir.
And meeting IDs, whatever, I'll be sending you. Always check your emails. You are habitual of watching only WhatsApp. So I'm not. I don't use WhatsApp for students. For students, email is the best, and because every teacher has to keep record of emails. They have to submit. Now, in the waiting room, I am admitting 2 more. And let me start the lecture. So on the screen, can you see? Can you see my screen, computer screen?
Yes, sir.
Can you see my lecture notes? Can you see this document?
Yes, sir.
Can you see my lecture notes on the screen?
No, sir.
Yes, sir.
You can't see this page, Word document. On your screen, anybody else in the on your screen, can you see this thermodynamics one that you page को मैं move कर रहा हूँ? My lecture notes are on screen. Can you see it? I am sharing my screen.
No, sir.
Nobody.
सर हमें नजर आ रहा है, इसके में क्या नेट नहीं ठीक।
किसको नजर आ रहा है?
जैन गौर सर।
जोर से बोलो, किसको नजर आ रहा है नहीं आ रहा, किसको नजर नहीं आ रहा, जोर से बोलो।
सर जैन
नजर आ रहा है सर।
क्या नजर आ रहा है? पढ़ के सुनाओ ताकि मुझे यकीन हो मैं लेक्चर शुरू करूं। आप देख सकते हैं रिवीजन ऑफ थर्मोडायनेमिक्स, पॉलीट्रॉपिक प्रोसेस।
यस सर।
हाँ चलो, तो अगर कोई प्रॉब्लम हो तो बताओ। अगर स्क्रीन गायब हो जाए, लेक्चर नोट नजर नहीं आ रहा है तो फिर बताओ। Bismillahirrahmanirrahim. We have learned in thermodynamics 1 polytropic process, isentropic process, and isothermal processes, and we have presentations like this. So work input for polytropic process is derived from integral PdV, and in the PdV we put P raised to n is equal to constant. From there we derive this relation, equation 324. So now we will need relationship P1 upon P2. Now Hey, what do you want? Hello? Now, so now I'm going to mute everybody, and if somebody wants to talk to me, he should unmute its mic. Now please mute your mics. Keep your mics muted, so your noise will not come in. Keep your mics muted. If you need to talk to me, then unmute it. Now, equation 324 and 25 in front of you. Can you see it?
Yes, sir.
Okay. So P1
No,
upon
sir.
P2 is V2 upon V1 raised to N. So this was derived in thermodynamics 1. Now we are talking about reciprocating compressors. In reciprocating compressors, we first draw this diagram, which is called PV diagram. So this PV diagram is called indicator diagram also, pressure versus volume. My God, disappeared. Here. So pressure versus volume diagram, process A, B. A to B, this is what is happening inside the compressor. A, B is the compression process, and its process formula is P raised to N is equal to constant, which is polytrophic process. D to 1, at P1 T1, pressure P1 T1, this line DA shows intake or induction stroke. 1, A to 2 is compression, and from B to C, exhaust at constant temperature P2 T2. In order to find these pressure and temperature at T2, we can use polytropic formulas, and work input is equal to, from this diagram, work input is the diagram area behind the curve. So this is equal to this. Actually, this chapter I have already taught you. I have already taught you this chapter before midterm, so I am revising it. So work input is equal to P given in this formula after after deducting this area from total area. So we get N upon N minus 1 P2 VB minus P1 VB. Actually, VB is equal to V2 and BA is equal to V1. So again, go to this diagram and you can see how it is done. So this total area is equal to work done. Look at this thing, A, B, C, D, A. This is the cycle. Work done in one cycle is area A, B, C, D. So total area under this curve P raised to N is first calculated, and then total area under this curve CB is calculated. Then sum of these two area we do minus this area below AD. So which is AD0 AD0F. So if you see this diagram and then see this formula, you can understand how it is done. Now in this way we derive equation 12.1. Then from equation 2.6, again thermodynamics 1, we know for ideal gas PV is equal to MRT. So that's why P1 VA multiply is equal to MR T1, P2 VB is equal to MR T2. From here we can convert volumes into temperatures. So this work input in a one cycle is equal to N upon N minus 1 MR T2 minus T1. Remember that this formula is only for this type of cycle where there is no clearance volume. Clearance volume is a space between top dead center and cylinder head. So it is assumed in this derivation that there is no clearance volume. Without clearance volume, this will be the work done formula. After this, we need temperature T2. T2 can be calculated by this formula. T2 upon P1 is equal to P2 upon P1 raised to N minus 1 upon N.
सर आवाज नहीं आ रही.
हेलो, आप अपना वॉल्यूम खोलें. हेलो, आप अपनी डिवाइस का वॉल्यूम खोलें. मेरा वॉल्यूम फुल है. हेलो हेलो, अपना वॉल्यूम चेक करें.
सर बहुत अटक के आवाज आ रही है आपकी.
आ रही है
सर तस्वीर भी नहीं आ रही.
बताओ, आवाज आ रही नहीं आ रही? जोर से बोलो.
सर अटक के आ रही है.
हल्की आ रही तो अपने डिवाइस हर एक का अपना अपना वॉल्यूम, किसी का बंद होगा, किसी का लाउड होगा. वॉल्यूम चेक करो.
सर वॉल्यूम खुला हो.
मेरा वॉल्यूम फुल है.
अटक के आ रही है, हल्की नहीं आ रही है, अटक के आ रही है.
सर समझ में नहीं आ रही.
अटक के आ रही है
जी,
अटक के आवाज आ रही है सर.
सर थोड़ी थोड़ी आवाज आ रही है. इसका मतलब
अटक के नेट का मसला होगा. आपका नेट स्लो होगा.
नहीं सर
आ रही है.
ओके,
चल रही है सर.
लेट्स गो अहेड. So
सर होस्ट के नेट का मसला होता है.
now we will finish here. So now there is an example solve 12.1. I'll give you this. It is in the book, and you will do at home. So let me open then another document.
सर पहला कंप्लीट हो गई
Conditions of now I'll give you another document that is where is this one. Now can you see my another document, revision of thermodynamics 1, 12 point, figure 12.4 in front of you. Can you see it?
Yes.
Okay. Now this topic of this document is
No,
positive
sir.
displacement reciprocating compressors, and we will derive now conditions of minimum work. Conditions of minimum work. Can you listen to me? Hello?
हेलो हेलो
Can you hear me?
Yes, sir.
Yes, sir.
नो सर
Can you hear me?
Yes,
नो
sir.
सर नो सर
Can you hear me?
Yes, sir.
नो
Hello?
सर
Can you hear me? Everybody can hear me.
Yes, sir.
सारे
Okay.
मिल के बोलो
Yes, sir.
Now, on this, can you see the screen also?
Yes.
Yes, sir.
नो
So-
सर
I don't understand. One says yes, other says no. How can continue my class? You have some problem with your own devices. You learn to operate with your devices properly.
The
Now,
network issue.
no jokes on the online. Okay, you are wasting my time. 30-minute lecture only.
नो सर
Now, A to B. My voice is coming.
Yes, sir.
और तरीके से बोलना. Yes, sir, बोलो.
यस सर नो सर
ये
Yes,
नो वाला
sir.
कौन है ब्लू का पट्टा? Now, A to B, A to B, A to B1, A to B2. These are three lines shown. Processes from A to B, A to B1, A to B2. So A, B central line, this central line between these two is PV raised to n is equal to constant, that is polytrophic process. This outer line AB is AB2 is PV raised to gamma, that is adiabatic, that is isentropic line. AB1 is the most desired line because it has least area of the cycle. A, B, C, D. This diagram makes a cycle. A, B, C, D is the minimum area. So we need, if we need that work input in a compressor becomes minimum, then we must operate compressor with cooling. That its temperature should not increase during the process of compression. So this is called as isothermal compression. So isothermal process is the most effective process from the point of view of from the point of view of minimum work input. So here also again we can calculate area like this. So total area ABCD is equal to area AB1CEF plus area AB1COE minus area. So this is geometrically can be seen from here. So this total area is equal to area under this curve plus area under this curve minus this area. So if we do this, we will write here this equation, and here area ABEF is equal to PV multiplied by log P2 upon P1, and from here indicated power can be calculated at E2 P2 V2 log P2 upon V1. Mute yourself, please. Don't make noise. Now, from here, we can calculate that work done isothermally is equal to MRT log P2 upon P1. Now, isothermal efficiency is defined as isothermal work divided by indicated work given by equation 1210. It is in front of you. Now, after that, you will solve example 12.3, it is in front of you. It is in the book and rewritten here also. Then there is a problem 12. It is also solved example 12.4. Then there is a solved example that these two solved examples are here, and you will see at home. You do it with your own handwriting and submit it as a homework. Then I'll give you separately to do homework with given day. So with this, I must go to next page, which is compressor work in a cycle with clearance. Up till now, you have seen polytrophic process, isothermal process of a cycle where there is no clearance in the compressor, and now with clearance, there's a lot of difference. Why? Because, now let me share again. So compressor work, can you see it? Now, on the screen should be compressor work with clearance. Am I right? Am I right? Can you see this page? Compressor work with clearance.
मैं नहीं
Yes,
बताऊंगा.
sir.
Okay. So let's go ahead. This is, this PV diagram is different from that which was shown previously on last two pages. But here, this is the clearance. Can you see CE? This space with my, I am showing with cursor. This space VC, and this is because after compression from A to B, there is a discharge valves will open, and at constant temperature and pressure P2, T2, gas will discharge. But one compressor is just to come back from top dead center to bottom dead center and reach here, this place, up to this place D, up to this point D. This is compressor, this is top dead center, this is clearance, this is top dead center, and this is after return to bottom dead center. But there was a gas trap in the clearance volume because suction and discharge were immediately, they are closed immediately after top dead center, and when from top dead center compressor moves towards right, towards bottom dead center, then outer fresh intake, fresh induction will not come unless previous gas trapped in the clearance is not expanded up to point D. So because of this, there is a lot of effect on the efficiency of the compressor. Compressor cannot take full induction because of this entrapped gas inside. So actual suction volume is less than the displacement volume. Displacement volume is just physical volume which piston travels from top dead center to bottom dead center, which is shown here as Bs. So Bs is the maximum volume available, but actual volume is AB. So VA, VD. So this is called induction volume. So work input in this case will be N upon N1 minus 1 MR32 minus T1, and indicated power with the help of area we can calculate like this. And indicated power finally is equal to equation 1211. And since temperatures can be converted into pressure, because we know that T2 upon T1, P2 upon P1 is equal to P2 upon P1 raised to N minus 1 upon N. With the help of this, we can calculate like this. So here V dot is the actual volume induced, which is equal to VA minus VD. And now this was for one cycle. Work required for indicated work for one cycle. If there are F number of cycles in per unit time, F number of cycles in 1 second, then we multiply this with F, and the formula will become this. So this is the final formula for indicated power of compressor, reciprocating compressor with clearance. So then you will do, after that you will calculate example 12.4, and this example will show you how you use this formula to solve the problem. So indicated power and all this. Now another type of solution is given here, two types. So with this we will stop today's meeting here, and time is over. Next meeting inshallah tomorrow.
Okay, sir.
Yes.